Lesson 3.1 is plotting points in a coordinate plane. So we're going to identify and plot points in a coordinate plane. The coordinate plane can actually be divided into 4 regions, and those are called the quadrants, and they are labeled with Roman numerals 1, 2, 3, and 4. And on this graph on the next page, I want you to go ahead and label them. So it's in the upper right-hand corner. We have 1, and it goes counterclockwise. 2, 3, and 4. Make sure it's IV and not VI because VI is 6. All right, now we're just going to go ahead and give the coordinates of each point. Remember, you start at the origin. Our coordinates are in an X, Y pair. You start at the origin, you go left or right, and then you go up or down. So if we look at point A, we're going right 2 and down 3. So it's 2, negative 3. Point B, we start at the origin, go left 3 and up 2. So it's negative 3, 2. Point C, we go left 3 and down 4. So negative 3, negative 4. D, we go right 3 and up 3. So it's 3, 3. And point E is right on the origin, and that is 0, 0. Next, we're going to go ahead and plot the points and describe the location. When you describe the location, you either tell what axis it's on or what quadrant it lies in. So point A, we start at the origin, we go right 1 and down 3. So right here, and we'll just label it A, and that's actually in quadrant 4, so we can just put a Roman numeral 4 there. Point B, we have left 2, down 2, and that's in quadrant 3. And point C is left 3, and then we don't go up or down. So this is on the on the x-axis, which is the horizontal axis. Okay, next. We're going to graph the function y equals a half x plus 2. They're going to give us the domain of negative 6, negative 4, negative 2, 0, and 2. And then they want us to go ahead and identify the range. Since we're graphing a function, we're going to go ahead and make this a continuous graph, which means we are going to connect it and make it a line. So all I do is just plug the negative 6 in. I'll show the work for the first one, and I'm pretty confident that we can do these in our head. So we have 1/2 times negative 6 plus 2. Half of negative 6 is negative 3, plus 2 is negative 1. So now we'll do the same with the remaining domain values. Half of negative 4 is negative 2. Negative 2 plus 2 is 0. Half of negative 2 is negative 1. Negative 1 plus 2 is 1. Half of 0 is 0, plus 2 is 2. Half of 2 is 1, plus 2 is 3. Plus, since this is linear, you should see the pattern right here. In these y values, the ranges are all increasing by 1. So let's go ahead and list the range. The range is, whoops. Oh, come on now. Negative 1, 0, 1, 2, and 3. And you know, since they're only giving us this for the domain, I did misspeak. This is a line. However, they're giving us specific domain values, so I have to have a specific range value. So this is going to actually be a just a bunch of discrete points again. So we have negative 6, 2, 4, 6, and negative 1, so right around here. And then we have negative 4, 0, negative 2, 1, 0, 2, and 2, 3. And yes, it is going to make a line. This will be the function of a line. But again, since they're giving us this specific domain, we're kind of locked into using this range, so we're not going to connect them. All right, if you choose to start your assignment early, here it is. It's lesson 3.1, pages 149 to 152, problems 1, 2, 7 to 13, 16 to 22 even, 22, 24 to 32 even, and 33 to 40.